This engine will change aviation forever. Recent Rolls-Royce modifications to the F-130 twin engine for the B-52 aircraft of the U.S. Air Force increase military aviation technology. The F-130 engine, which powers the B-52 Stratofortress bomber, has been a key Air Force engine for decades. However, Rolls-Royce has upgraded the F-130 engine to improve performance, economy, and capabilities. To keep the B-52 current and effective in modern combat, certain upgrades are made. Upgrades may boost thrust, fuel efficiency and maintenance, and engine control and monitoring systems. Upgrades seek to extend the B-52's operational life, allowing it to perform important mission tasks. Rolls-Royce's efforts to improve the F-130 engine shows its aeronautical engineering competence. They are modernizing the B-52 fleet alongside the U.S. Air Force and other partners to meet 21st century operational objectives. This issue illustrates the interplay of cutting-edge technology with military strategy and the need for continual research and development to keep aging aircraft viable in a changing environment. Improvements to the B-52's F-130 twin engine will affect the whole fleet. A long-lived strategic bomber, the B-52 Stratofortress has shown its adaptability and usefulness in combat missions. Modern warfare requires modernization and upgrades to keep it effective. These advancements' significance and impact. Increased performance. The F-130 engine modifications may boost B-52 thrust and performance. This increases speed, range, and operating flexibility. The B-52's usefulness in a rapidly changing global security context depends on these upgrades. Extended operational life. These upgrades might prolong the B-52's fleet lifespan by decades. This is crucial because it allows the Air Force to use this proven platform while eliminating the need to introduce new aircraft. The cost savings. Long-term cost reductions might arise from fuel economy and maintenance improvements. Modernizing the B-52 allows the Air Force to focus on other important areas while preserving a highly capable bomber force. Adaptability, strategic nuclear deterrent, conventional strike, and intelligence collection have all been performed by the B-52. The B-52 can adapt to new threats and fly more missions with improved engines. Strategic flexibility. Improved engines allow the B-52 to carry bigger payloads over longer distances, enhancing its versatility. The Air Force needs this flexibility to adapt to shifting geopolitical factors. Force multiplier. Improving the B-52's fleet engines fits the force multiplier principle, where a few platforms may have a big impact on the war. A smaller fleet of modernized B-52s can perform as well as a bigger fleet of less competent aircraft. Technological integration. Engine management and monitoring systems may have improved the F-130 engine. Advanced digital warfare and networked battlefields keep the B-52 current with its cutting-edge technology. Collaboration with the United States Air Force and Boeing. Rolls-Royce, the U.S. Air Force, and Boeing worked together to integrate the improved F-130 engines into the B-52 fleet. This trio of experts has collaborated to test and integrate F-130 engines to the highest performance, safety, and operational effectiveness requirements. The expertise of Rolls-Royce. Rolls-Royce provides their engineering expertise and experience as the F-130 engine development to the cooperation. They've produced sophisticated engines and guided the integration process to assure B-52 platform compatibility using their engine, design, production, and testing expertise. Air Force operational insight. The U.S. Air Force is essential to this collaboration. Their years of B-52 fleet operation give them unique insights into the enhanced engine's operational requirements and limits. Their experience customizes F-130 engines to the B-52's demands and mission objectives. Boeing Aerospace expertise. Boeing, the B-52 maker, is crucial to integration. Their aeronautical engineering and production skills are essential to fitting the F-130 engines into the B-52's airframe. Boeing's structural and aerodynamic knowledge helps integrate the improved engines. Testing and validation. The collective effort requires thorough testing and validation. Rolls-Royce, the Air Force, and Boeing perform comprehensive ground and flight testing to guarantee the B-52's F-130 engines work properly. These tests include conventional flying circumstances and more difficult mission profiles simulations. Iterative improvement. Collaboration goes beyond integration. Analyzing testing and operational usage feedback, tweaks are made to optimize engine performance and compatibility. This iterative strategy keeps F-130 engines up to date with the B-52 fleet's changing demands. The strong partnership between Rolls-Royce, the Air Force, and Boeing shows how knowledge, ingenuity, and devotion can effectively modify and modernize a legacy aircraft. This partnership shows these entities' commitment to operational excellence and the collective effort needed to advance aviation technology and keep the B-52 a powerful asset in modern defense strategies. Testing and integration process. Rolls-Royce has begun testing F-130 engines for the B-52 aircraft in its cooperation with the U.S. Air Force. This vital step in modernizing and improving the B-52 bomber shows Rolls-Royce's dedication to cutting-edge aviation technologies. The testing phase is carefully planned and implemented to verify F-130 engine performance, reliability, and B-52 airframe compatibility. These testing include ground and flight trials to replicate operational scenarios and conditions the aircraft may face throughout its missions. F-130 engines are rigorously tested on the ground to ensure their operation, power output, and reaction to instructions and inputs. These tests discover and fix flaws before the engines are installed in the airplane. Engineers, pilots, and technicians may test engines in real-world flying situations during flight trials. These trials evaluate engine reactions throughout takeoff, climb, cruising, descent, and landing. The engines are further tested under various flight profiles and mission scenarios to ensure reliability and efficiency in various operating settings. Rolls-Royce's rigorous testing process shows its commitment to creating engines with the highest safety, reliability, and performance requirements. The company's proactive approach to identifying and addressing difficulties early in the development process reduces risks and maximizes integration success. Rolls-Royce is making progress towards offering a cutting-edge solution that improves the B-52 fleet's capabilities and keeps it relevant in current military operations by testing the F-130 engines. This phase culminates painstaking planning, engineering expertise, and industry-military partnership to equip the B-52 with engines that address 21st century defense concerns. Benefits and features of the improved F-130 engine. The F-130 engine for the B-52 fleet has been improved in many ways, making it a more reliable and adaptable aircraft power plant. These engine design, operation, and control improvements optimize operating capability and resource management. Some major advancements and their effects. Number 1. Increased thrust. Increasing engine thrust is a major improvement. This push boosts aircraft acceleration, maximum speed, and maneuverability. The B-52 needs these enhancements to quickly adapt to changing mission objectives and operating conditions. Number 2. Improved fuel efficiency. The F-130 engine's combustion technology, aerodynamics, and materials have enhanced fuel economy. This improvement reduces operational expenses and increases the aircraft's range and endurance, allowing longer mission durations and additional deployment alternatives. Number 3. Lower maintenance. Engine design and materials innovations reduce wear and tear, reducing maintenance and extending service intervals. This improves B-52 operational readiness by increasing aircraft availability, reducing downtime, and lowering maintenance costs. Number 4. Advanced engine control. The F-130's engine control systems are more accurate and responsive. This fine-tuned control optimizes power delivery, fuel consumption management, and pilot inputs, improving aircraft performance and efficiency. These modifications support modernizing the B-52 fleet for modern military operations. Rolls-Royce has improved thrust, fuel efficiency, maintenance cycles, control systems, and dependability to make the F-130 engine more powerful. The B-52's performance envelope increases, making it more nimble, cost-effective, and versatile for the U.S. Air Force. Significance for the B-52 fleet. The B-52's Stratofortress relevance and effectiveness depend on the F-130 engine's upgrade. This improvement transforms the aircraft's capabilities, allowing it to adapt to contemporary combat and lengthen its service life. Why the F-130 engine upgrade matters? Number 1. Improved performance. The updated F-130 engines boost thrust, improving speed, acceleration, and maneuverability. This increased performance allows the B-52 to swiftly respond to new threats, execute complicated mission objectives, and retain air supremacy in disputed settings. Number 2. Extended range and endurance. The B-52's operating range and endurance increase with fuel economy. Reduced fuel usage allows the aircraft to fly farther and stay on station longer. This increased range allows the B-52 to perform strategic deterrence, long-range attacks, and information collection worldwide. Number 3. Mission profile versatility. The B-52's mission versatility is greatly improved by the F-130 engine enhancements. Increased thrust and control systems makes the aircraft superior for pinpoint attacks and long-range, heavy payload missions. This adaptability is essential for adjusting to contemporary warfare's changing operational needs. Number 4. Operational efficiency. The upgraded engine design reduces maintenance, increasing aircraft availability and lowering expenses. This operational efficiency keeps more B-52s ready for deployment, improving the Air Force's preparedness and responsiveness. Integration with modern technologies. Modern avionics and communication systems may be compatible with the F-130 engine upgrade. This connectivity allows the B-52 to easily collaborate with other assets, share real-time data, and operate in the network-centric battlefield, improving situational awareness and mission effectiveness. Cost savings. Increased fuel economy and decreased maintenance save the airplane a lot during its lifetime. This frees up resources for essential defense programs and modernization. F-130 engine improvements turned the B-52 from a famous aircraft into a formidable asset. The F-130 engine makeover keeps the B-52 crucial to the U.S. Air Force's strategic capabilities by improving its performance, range, adaptability, and efficiency. This upgrade meets contemporary warfare's needs and emphasizes the need to adapt, develop, and exploit old platforms in a quickly changing environment. Don't forget to like, share, and subscribe for more thought-provoking content. And hit that notification bell so you never miss an update.